We have to write 3 times composition.
Okay. So x of t is equal to a cos omega t plus 5. Okay, that is your x of t, the displacement. That is the displacement. Okay. Now, when you represent it using a wave, how will you represent it? It's a cos wave, right? It's a cos wave.
Up and down.
This is how you will represent displacement. This is how you will represent displacement. So this is x of t and this is t. What will be this? That is the amplitude. Amplitude means this is the amplitude part, the maximum displacement. So you should understand this, okay? This is not just for this year. You will need this later also. So this will be the amplitude. The coefficient of cos or sine function will be the amplitude. So over here, A is the amplitude. So this will be plus A and this will be minus A. In grade 9, you studied a wave oscillate between the plus A and minus A. So this is what it is. This was your x of t. Now listen, I will give you time.
What is amplitude again?
The maximum displacement.
Like
This is when A and minus A. This is amplitude. In the equation over the coefficient of force. Now what was velocity? Read the equation of velocity. V of t is equal to.
Minus omega root of 1 square minus x square.
No, in the equation form you have after differentiating. It is d by dt of x of t. When you differentiate, you will get A into minus sine omega t plus 5 into omega. So minus A omega minus A omega sine omega t plus 5. So for this displacement was a cos function. For this displacement, what will be velocity? Is a sine function. Negative sine function is velocity. Okay. So normal sine you know how to draw. This is sine.
And where did the omega come from?
What?
That one out here.
Differential of omega t is omega.
Oh.
Okay. So this is the normal sine curve. Minus sign means how it will be just ulta of this. Negative sign. Okay. So the velocity curve will be negative of sine curve. So this will be that curve. Understood? And this will be x of t. And this is t. And what is the amplitude here, Royden? What is the amplitude?
Minus A and A.
Minus?
A and
Minus A omega. That is the amplitude.
oh,
This is the amplitude, right?
Isn't just A amplitude?
Whatever coefficient of sine or cos is the amplitude.
Oh.
Okay. So this will be minus A omega and this will be plus A omega. So this is a waveform of displacement and velocity. Theory we studied, this is a waveform. Clear? Is it okay all of you? Okay, complete this. Waveform of displacement, waveform of velocity. This is displacement curve, okay?
I think so.
Displacement curve. What?
both the diagrams.
Yeah? Velocity curve.
Usually.
Velocity curve.
Yeah.
Equations, right? All the equations also.
And she's already enough in this.
That's what happened. You only said
Is it test?
you studying from the private.
I mean, you want to test?
No thanks.
From studying. I didn't know.
That's it.
Last day when you wanted to see.
Imagine you do or chicken. And we laid 100 eggs. Imagine if we shut your mouth. Would you give 250 eggs every night? While I imagine that.
Finish, right? Okay. So next derivation is acceleration.
Displacement.
What happened? All the way to people where now?
What?
I don't know what happened. I speak in English, man.
I understand what you told first, but something else.
What was that? 4, 5, 6. Which one? Velocity was 3 or 4? Velocity. The number for velocity.
Five.
Velocity was 5.
Yeah.
And acceleration is 6.
Like that.
Acceleration 6. So how will you get acceleration?
dv by dt.
Differential of velocity, you will get acceleration. Acceleration is dv by dt. What is v? Minus a omega sine omega t plus 5. This was? You will take this one, okay? This equation. This equation we will take. Okay. Now, differentiate. How will you differentiate? Differentiate and tell. Dhyan,
Yeah.
tell me. Differentiate and tell. Dhyan.
No.
Yeah.
Differentiate down.
That's what she's asking now.
You have to differentiate this.
Yeah, yeah.
Negative a omega cos.
In the differential of sine is
Cos.
cos.
Omega
Omega t plus 5
and
It's not that hard.
into omega. Differential of omega t is again omega. So it will be minus a omega minus omega square a
Cos.
cos omega t plus 5. What is a cos omega t plus 5? X. So acceleration is minus omega square x. Understood? Okay. Now you have to put a graph. So this is a graph. It's a cos. Graph will be cos but negative of cos. This is a cos graph but negative cos graph. Ulta will come. Normal cos graph is like this. So minus cos graph means it will be like this. Okay. What will be the magnitude? Minus omega square a. Omega square a. Clear? This is the graph. Clear, right?
What is A?
Amplitude.
Like calculate A capital itself.
Yeah. And then you add it with the constant.
What's the constant?
Omega thing.
Constant is omega.
Oh,
Oh, damn, man.
Yeah, understood. Crazy.
Yeah, easy.
You
Yeah,
because
yeah.
zero
It's a
position
feature.
of maths.
Yeah, only the use after
Yeah. No, he's on it.
No, he's on it. He's sick apparently. Yesterday, yesterday he sat at
Oh, yeah.
I was sick. Yeah, I was sick.
That's it.
Yeah. Steve, why did you come? Because of your haircut, yeah.
Finish. What happened?
And he didn't come because of his haircut.
What?
He got haircut.
Yeah, his haircut, yeah. Yeah, Steve, you're not coming because of your haircut, yeah.
Gotcha.
No, I'm sequel.
Okay. Draw the waveform master. Completed. Okay. Next is force. Yeah. Force, time period, frequency, energy. After that, only two more topics. Then this chapter is over. But those two topics I'll be taking later. After finishing all this, we will be doing problems. In one more class, this chapter is over. Huh?
Yeah, you don't have AG.
Problems there. Like concept, like they deleted a lot. Finish, right? All of you? Okay. Next is force in SHM. Force in SHM.
Force in HHS.
Force in SHM.
Why are you staring at my toes, man?
It's scary.
Like this stuff.
Force in SHM.
He's staring.
Not.
Force in SHM.
All this is for SFM, right?
Yeah. Force in SHM. So,
Indirectly.
Okay. So we know F is equal to what? F is equal to MA. And what is the acceleration which we just got? Minus omega square x. So what was Hooke's law?
Negative K square.
What?
We have F is equal to minus kx. So from here, what you will get? Therefore, k is equal to m omega square, right? Correct? F is equal to minus kx. Hooke's law. Huh? Spring.
Where did K go? Oh,
K is m omega square.
Yeah, switch man.
K is m omega square. Okay.
Hey,
So-
what's about force? Oh, wait, we substitute done.
Yeah.
Easy, bro. It's not hard.
K is the force constant. What is the unit of K? Dhyan, what is the unit of K? Zian, what is the unit of K?
Yeah.
K unit.
It's a constant, right?
It's a constant.
Yeah, but it has
Force by X. What's the unit of force?
Newton में
Newton per meter.
Yeah, she's literally forced by.
force by x.
Yeah, what is it? This is the.
It's displacement, not
Yeah, displacement of the same unit only.
No,
Hey, why did you go so
distance and displacement are different. I know the difference between this and this.
Exactly.
Can't tell.
You want to put different, and you have to be like all the difference, and then you'll see exactly. Come to the.
Why do you even cover this? Why do you even cover this part?
Yeah, he's medium color. Yeah, medium color.
You're not medium, right? I'm medium. You're like,
Okay.
Good boy.
So force in SHM is done. Now next is time period in SHM.
time period.
Omega is
Oh, God.
angular frequency. 2 pi m.
I was wrong here.
Time period.
What is theta?
Omega is displacement by time, theta by t.
Yeah, what I was wrong. I don't think it's just theta. It's
Okay. Now next is time period. Time period of SHM.
A lot.
How much time will it
How much?
dimensions?
These are all small, so how can you call it as a derivation?
But like how much?
Are you struggling?
Time period, frequency, energy.
Yeah, after that,
After that, problems.
Oh.
Then next class, 2 more.
Oh.
That's it.
after that,
That's only
After that, this chapter is over.
After the next chapter.
Next chapter, waves.
Oh.
I only remember
I have to check. I don't remember.
Oh.
Okay, so time period. Time period. Okay. So what is we have what is K? What is K?
M,
M omega square.
So omega square is what? K by M. Omega is root of K by M. Omega is what? 2 pi by time period. Agreed? Correct, right? Omega is 2 pi by T.
Yeah, I agree.
Root of K by M. Or time period will be equal to 2 pi root of M by K.
No, it's a 9 count.
2 pi root of M by K. Correct, right?
6, 7, 8, 1.
3 lines.
That's a good thing.
No.
Yeah.
Finish? Finish. 2 pi by T. Engana. Omega is basically angular velocity, which is displacement by time. In circular motion, displacement is theta. Okay? So full circle, theta will be 2 pi. And time taken for one complete circle is time period 2 pi by T. Okay? Done.
I don't think you can finish.
Madam, what?
I don't.
Finish.
Yes.
Then find frequency. 9. What is frequency, Royden?
The formula
1 by
Frequency.
1 by T.
1 by time period. The frequency will be just reciprocal of this.
Yeah.
Oh, that's so easy.
1 by 2 pi. Physics is easy only.
Yeah, it's
Yeah.
you told it's easy, yeah. You have to do it.
Frequency is 1 by 2 pi root of K by M. Yeah, Royden. Correct.
Yeah, 1 by. Yeah.
Oh, it's so cold.
It's new.
Off the
Look at that.
It's new, right?
Yeah, new.
Oh no, it's hot. It's
You can write.
All like that.
Okay.
What are you writing about?
So frequency is done. Next is energy in SHM. Last one in this type, okay? Energy in SHM. Elona, have you studied velocity derivation which I asked you to study? Huh?
Oh. No, what is why is why are writing it?
Huh?
Why are writing that?
I can take a photo and put it in the group.
Ma'am, you ask online people then do also.
Huh?
Online
Oh yeah.
Yeah. I love.
Ask Steve, ask Steve.
people.
He studied.
Yeah.
Yeah.
Yeah, he didn't come here though.
Okay. So 10th one was energy. Energy in SHM. Energy in SHM. Ah.
Not.
Okay, it's fine. I will.
Yeah, that,
I will
Fix. That's it.
Screw is there?
is there a screw?
Still there?
Something is missing.
Okay, it's fine. I'll put the new screw.
I wonder. Yeah. I did not do anything.
I wonder what you are.
What happened? Oh.
We are okay now. Bad yesterday, last week.
Yeah. Okay, finished, right? Finished. Okay, right. Energy, what all energies will be there for a SHM, a particle executing SHM? What all energies will be there? Kinetic and
Potential.
potential. What will be the formula for kinetic energy?
Half and
Half mv square.
Half mv square. What will be the formula for potential energy?
Yes.
Half kx square.
Oh yeah, spring. Oh.
It's spring, half kx square. So what you will do is, you know the velocity formula. You know the velocity formula. Minus a omega sine omega t plus phi. That you know. So you'll put that in half mv square. You will get kinetic energy. Okay. In half kx square, in place of x, you will put a cos omega t plus phi, the displacement formula. So you will get potential energy. What is mechanical energy?
Yeah.
Or total energy will be the sum of these two. When you add, you will get the final answer. That's it. Easy derivation. Okay, right. A particle executes SHM. A particle executes SHM. Executing SHM. A particle executing SHM has kinetic and potential energies. Has kinetic and potential energies. Yeah, that bottle you can get. The big bottle, green. Yeah. A particle executing SHM has both kinetic and potential energy, varying between the limits 0 and maximum. Varying between the limits 0 and maximum. Varying between the limits 0 and maximum. Okay. So kinetic energy is equal to half mv square. What is V, Akash? What is V?
E minus omega. Omega root a square minus x square.
That is the final formula, but you will take this one, minus a omega sine omega t plus phi square. Okay, so you will get it as half. What is m omega square? What is m omega square?
M omega square that.
What is m omega square? K. M omega square is k. Okay.
Yeah,
So minus half k a square sine square omega t plus phi. Okay. Now what is potential energy formula, Pranav?
Potential energy formula is half mgh.
Half k square. Spring potential energy of a spring.
Oh, it's
Half k square, right?
This is negative. If it gets square, then positive.
Negative. This
Oh,
negative.
yeah, it's got.
No.
I mean, it's not.
Wow.
Yeah, you take it out.
No, it will go.
Yeah, see, I mean,
It will go.
told you.
Yeah. Now what is potential energy? Half k square. Half k square. So what is displacement? Half k. Into what is displacement? Dan? What is displacement? This what is the formula?
And that might be it.
I will just say
Right is to trade cost.
yeah.
It's fine, yeah.
A cos omega t plus phi.
What do you do?
Now this will be equal to half k a square cos square omega t plus phi. So what will be total energy? Kinetic plus potential. Total energy will be kinetic plus potential energy. This will be equal to half Ka square. You can take common, right? Sin square omega t plus 5 plus cos square omega t plus 5. What is this? Sin square theta plus cos square theta, Elona?
One. There's like a
Negative.
Squared and bone.
Yeah.
What is sin 1? This will be 1.
One.
So what is total energy? Total energy will be half K A square.
In the second line of the kinetic energy derivation here, isn't there a minus inside the bracket?
Yeah, minus is there. When you square only, it will go. Yes. Correct. What happened? You can't see.
I'm gonna watch that one.
I did.
Okay, I'm gonna watch this.
It's kind of scary.
I want a mini controller. You can do it for me. Yo. No. Get over it. No, into that.
Yes. I don't know. You don't need.
Yeah. Your friends or you.
You're too good. You're good for friends. Yeah.
Exactly.
Yeah. That's chocolate for you.
No, I have. No, we are adding enough because.
One eye. It's only one eye left.
Oh yeah, yo, that's hard. I said.
I'll cut it all like.
Okay, that's this is a challenge for you.
Oh, this is such a challenge.
No, this is a challenge for Zia.
It's for me. Oh, okay. So
After that, you will take.
I mean, it's imagine such a challenge. It's such a skill issue that you don't.
They all having
So
fun.
hard. Which one are which method are you using?
Think of Rocky, they will come and half was like to find.
Yeah, you are using beginner version. Yeah. You are using beginner level. And you are picking up
Don't have that.
Oh, yeah, I don't know. What did I do? I didn't even change it. He twisted collar. I did not twist.
You twisted the wrong color. It was orange, white, blue color.
Yeah, orange, white, he actually twisted collar.
Orange, white, blue color. Orange, white, blue color.
What orange, white?
It's easy to.
Oh yeah, that method, yeah.
I know, we did not. You twisted the other one.
Okay. Finished, right?
I did not do that one.
Okay.
Oh.
So now you have to draw the curve. Potential energy and kinetic energy curve.
The total.
The total energy curve.
Yeah, that's
Remembering same as in spring. Draw
yeah.
the curve.
Same as in what split?
In case of spring.
energy.
Oh, that.
Yeah.
Right.
I do it. This side.
What is the title bar for this then?
What?
What is the title for this?
So the curve for the energy.
Oh, like
Why? We need that.
this.
It's like this.
I think it's this.
Yeah, that's.
Is it? Yeah.
It's in the textbook, right? You do not see it, man.
No, she's talking something else.
Let's see.
I'm gonna.
Cartesian.
We saw another level.
Which is what?
Oh.
That is the big.
Hey, Diamond, you got it wrong.
No, I didn't get it wrong. I got it right. I
He lost his.
Have you ever done that?
Yeah,
You learned the chapter.
no, not this chapter.
Exactly.
We learned the spring.
Oh, and then the difference.
Yeah, it's that thing over
The
there.
parabola.
No, double parabola.
Double. Yeah.
So at the maximum displacement, we call this will be A and this will be minus A. At maximum displacement, what is zero? At the maximum displacement, what is zero?
Kinetic energy.
So this will be kinetic energy and kinetic energy will be
Maximum.
no. At maximum displacement, kinetic energy is zero, right?
Yeah.
At maximum displacement,
Kinetic is zero.
kinetic energy is zero. This is kinetic energy. So this is the mean position. At mean position, kinetic energy is maximum. Okay. At maximum displacement, kinetic energy is zero. And this will be potential energy. Potential energy is maximum at extreme positions and potential energy is zero at the mean position. Understood? Total energy is always the same. Total energy is always kinetic energy plus potential energy. Same curve which you studied in work energy power chapter.
Oh.
What?
Why you can't sit alone?
You
can't.
say.
No, ma'am, it's there, like actually otherwise.
Yeah, come here. I need hands support.
What?
My table, bro. I mean,
The answer is hands up here.
Another table.
He said they are support.
Draw completed. Understood? Yeah? Explain. Rayan, explain, Rayan. Explain this kinetic energy curve. Where is kinetic energy maximum and where is kinetic energy zero? Tell me that.
Look at your book.
Kinetic energy is maximum
At the.
at the
On the right.
there are two conditions, mean position as well as the extreme position, maximum displacement and mean position. Kinetic energy is maximum at the mean position. This is kinetic energy with curve. Kinetic energy is maximum at the mean position and kinetic energy is zero at the extreme positions or maximum displacement. What about potential energy? Potential energy is zero at mean position and maximum at maximum displacement positions. Clear, right? Okay. Right? Total energy of an SHM is independent of time. Total energy of SHM is independent of time. Total energy of SHM is independent of time. Now we will do problems.
Your total energy.
Okay, total energy of SHM is independent of time. Completed, right? Okay, we'll do problems. So basically in this chapter, two more topics left. Applications of SHM. In that force, spring is coming, simple pendulum is coming. Spring we already studied. Spring force we already studied. The same thing, it will come under application. Then simple pendulum 2 pi root of L by T derivation. That derivation will come. Then there is a theory topic that is that was comparison between SHM and circular motion. That was coming in between. That was an in-between portion that I skipped, that we will study at the end. So now we will do problems. Our problems based on till what we studied. Consider an SHM. consider an SHM. An SHM. X of t is equal to x of t is equal to 2 cos 4 pi t 2 cos 4 pi t plus pi by 6. This is the equation.
5/6 is what? 5/6 is what?
I can see.
Pi is what? Mega pi is what? 180 by 6 is what? 30.
Out loud. It's her, not I didn't know.
You wrote this equation?
Yeah.
Yeah, good, bro.
2 cos 4 pi t plus pi by 6. Done, right? Where x is in meters. Where x is in meters. Where x is in meters and t is in seconds. Where x is in meters and t is in second. Determine the time period. Determine the time period and initial velocity. Determine the time period and initial velocity of the oscillating body. Determine the time period and initial velocity of the oscillating body. Yeah.
My God.
Oh,
No.
Let me
Do the question. You see the line.
Okay, now listen. Listen. So, what is given? Displacement is given. What you need to find is time period and initial velocity. So, how will you find time period? 2 cos. Compare this with the standard equation, right and both. Listen, okay, this type of questions you should understand. Definitely one question will come from this chapter. Okay, like oscillations and waves together. If you understand this waves chapter also questions is of similar type only. So basically you should understand the equation. What is the equation? X is equal to a 2 cos 4, what is it? 4 pi t plus pi by 6, right? Okay, compare it with the standard equation. What is our standard equation? A cos omega t plus 5. Always do like that. X is equal to A cos omega t plus 5. See, amplitude is what? 2. Omega is what? 4 pi. Phi is what? Pi by 6. Understood? This is how you will compare. Understood?
Yes.
Now omega is 4 pi. What is omega formula? 2 pi by t is the formula for omega. Omega is 2 pi by t. Here omega value is what? 4 pi. So what is t?
Oh, that formula.
Oh. If you understand, this is very easy.
You understood? Yeah.
What's his name?
Now velocity. How will you get velocity? Differentiate this.
You can't do root a square minus x square formula.
X you can do, but can you do that? Root of a square and x square, root of that you will be able to solve? Okay.
Math abilities.
Huh. So V is equal to dx by dt. So you differentiate this. V is equal to dx by dt. So you will listen. Ivan, if you talk, he won't study.
I'm studying.
Dx by dt. So 2 cos. So differential of cos is what? Minus sine. 4 pi t plus pi by 6. What is the differential of 4 pi t? Zian? What is the differential of 4 pi t? What is the differential of omega t?
That's omega.
Omega.
Oh,
So 4 pi t it will be 4 pi.
4 pi.
So into 4 pi will come. So you will get 8 pi minus 8 pi sine 4 pi t
That's it.
plus pi by 6. Now they ask what in the question? Initial velocity means what you have to do? Substitute small t as 0. Velocity at t is equal to 0. Minus 8 pi sine. This will be going 0. Pi by 6. What is pi by 6, Alona? 8 pi sine 30. What is sine 30, Akash? 1 by 2. So minus 4 pi meter per second. That is the answer. Ryan understood. Negative sign shows compared to x, v is in the opposite direction. That's it. Okay, Akash understood.
4 pi t is
Put t is 0. Initial velocity. Initial velocity means when time t equal to 0. Elona, when are you traveling?
Sunday.
This Sunday. Oh, when is housewarming? 23rd. Before Christmas. When are you coming back? 27.
Everyone was going somewhere. I'm not coming. I'm online on Monday. Only you alone.
Sandra is also good.
Why is T 0?
Initial velocity they asked us to find. Initial velocity means time is 0. Sorry. Finished?
sunrise.
Yes. Sunrise and Bhavans is having annual day today.
Sunrise.
Bhavans. Hey. Huh? Just the building only.
What's on sunrise?
You can see that registration. law.
Yeah, what is it like sunrise?
Is that sentence?
Akash,
You saw?
what school are you?
Yes.
That's why.
I don't want second class anymore. Bekar school, I guess.
Yeah.
What?
What school are you?
Bekar school.
Gems. Bekar means useless.
They work for bombs.
Very strict. Like the nerd school. I like BRS. I like Gems. Yeah, exactly. Mayur is just rich people school. House Mayur.
Finished, right?
Yeah.
This is done.
Yeah.
Mayur.
So we get food menu.
Yeah.
You can hear me?
Yes.
Yeah, it's pressure on the
Oh, okay, fine.
You know,
Okay. Now next question. Right. Next question you will do by yourself. Okay. Same concept. Do by yourself.
No.
An SHM is represented by SHM is represented by
അപ്പൊ ഇങ്ങനത്തെ ടൈപ്പ് ക്വസ്റ്റ്യൻസിൽ SHM തരും.
and SHM is represented by x is equal to 12 sine 10t plus 0.6. See, you know, Addis Murud finished their portions.
Oh.
Physics. They have the first, they have the first pre-board for 11th on January. Bhuja is having, remembering Bhuja last year?
That's optional. Yeah.
They have first pre-finals in pre-finals in January. Pre-finals. First book full, second book 3-4 chapters from second book. They finished physics portion. It's not PT3. This is pre-finals. First book full. Second from second book 4 chapters.
That's bad. Yeah, that's good.
And see which chapter you are in now. They already finished the portions. Okay.
Same.
Other latest.
Okay. SHM is represented by this. Find out amplitude, angular frequency. Find out amplitude, angular frequency,
Angular frequency.
Find out amplitude, angular frequency, comma frequency, time period, and initial phase. Initial phase.
Angular phase, yeah.
Amplitude, angular frequency, time period, initial phase. If displacement is measured in meter and time is in second. If displacement is measured in meter and time is in seconds.
Actually. Already crossed off.
Hello? Do. Whichever school you learn, it's fine. Your 12th certificate matters. Whatever school you study.
But experience also should be good, no? GRS is crazy. It's actually so much stress.
Rian, you're in which school? No, sorry.
I can't forget the words. What's 5 stand for? Phase. Wow, or phase.
Ifya is also having annual day today. Ifya, Bhavan, Sunday is all annual day.
Frequency you have to find here.
Yeah, but
We have to find.
how we know? Why are your frequency? All omega T is given. Do it, man. Phi is given.
To substitute 5 as 22/7.
Pi, you leave it as it is. Pi don't need to substitute. Okay, leave as it is.
Wait, angular frequency.
You got it wrong.
No, I'm doing more than
Right. Then just retarded. 0.3. What is 5 times?
Is average frequency or something? Hopefully.
0.0. Answer is that the Mark 1. 0.6.
Just time period. Time period. Yeah.
What is
Not
Which one?
angular frequency, it's normal frequency.
Not all. I had to do
Angular
phase and
frequency
displacement.
and normal frequency.
I had to do initial phase. Yeah, I had to find the displacement. No. Only phase. Yeah. Yeah, only phase. Which one? Five. Yeah, it's 0.6.
That's phase.
Yeah. Then it's finished. Yeah.
Is that simple? Finish. First 3 seconds.
Yeah,
Okay,
it's easy.
so what is
We
amplitude?
find initial phase.
What is it?
And how do we find initial phase?
Initial phase is the phase when time is 0.
Okay.
Whatever is coming inside sine when t is 0. Okay. Ryan, what is amplitude, Ryan? You don't know amplitude. Why?
Oh, yeah, 12, 8, okay, 12.
Pranav, what is angular frequency?
The frequency. I don't know.
That angular
It will be
and bobble.
pi by
Hello. From the equation.
Angular frequency. It's already there.
It is omega
Yes.
t.
It's
Omega.
It's 10. It's 10.
10. Ryan, what is angular frequency? How? You got 10? Which equation? Omega. What's the unit, Elona?
Tell me the
Rand.
Second raised to minus.
That is time. What is that? Second raised to minus 1. What is unit of omega? Royden, what is the unit of angular frequency?
The frequency. Radian per second. No.
Radian per second. Theta by time period. Displacement by time, right? Yeah. Akash, what is the unit? Radian per second. So 10 radian per second is angular frequency. What is the normal frequency, Zian?
oh, it is 1 by 0.2 pi.
Yeah. It's correct only.
Bro, you.
Yes.
A sine omega t plus phi. A is 12. What is the unit of displacement, Dhyan?
What is amplitude units?
What is
It's in meter.
Ma'am, what is amplitude units? Does it have any?
that is what I asked now. It is meter.
Unit of displacement.
Omega is 10 radian per second.
Amplitude is
Frequency is omega is 2 pi f. So f will be omega by
What is
2 pi.
phase?
10 by 2 pi.
yeah 5.
5 by pi. What is the unit? Hyman.
Yeah, unit is this thing hertz.
What else you need to find?
No, it's correct only. It's 1 by 0.2 also gives even.
I period.
What is time period?
Ulta.
Time period is 0.2.
2 pi by omega.
Correct only.
Ma'am, what is phase unit?
She had no reaction.
No.
Time period is in second. Now initial phase means initial phase is the phase when phi t is equal to 1. Here you put t is equal to 1. This is the phase. Put t is equal to 1. So phi will be equal to 0.6 radian.
Never mind.
0.6 radian will be phase. T1 now.
I typed it wrong.
Time period is 0. Put time period as 0, okay, not 1. Initial phase means put time period 0. Finished? Finished, right? Not 12. Okay, write the next question. Sabha, are you getting?
Yes, ma'am.
Okay, write the next question. A body describes SHM. A body describes SHM. A body describes SHM with an amplitude of 5 centimeter. With an amplitude of 5 centimeter and a period of 0.2 seconds. And a time period of 0.2 seconds.
Amplitude of.
Steve, you should write units for everything, okay?
0.2.
No, I didn't. I was wondering why is it second?
Second.
A body describes SHM with an amplitude of 5 centimeter and a period of 0.2 seconds. Find the acceleration and velocity of the body
Okay,
Acceleration and velocity.
Find acceleration and velocity of the body when displacement is 5 centimeter and 0 centimeter. Find acceleration and velocity of the body when displacement is 5 centimeter and 0 centimeter. So for displacement 5 centimeter, you have to find velocity and acceleration, as well as for displacement 0 centimeter, you have to find. Two cases separately you have to find. 0 centimeter. Am I school finished? Next week also. So Rohan will be missing.
Yeah.
My school
He's missing
finished.
one
See, Jack's henceforth better.
Okay, okay.
You're not standing.
What? No, that one. Yeah.
I'm an
Who's helping me out? I was helping you out.
I know.
You get the
Okay.
5-1?
So
Did you get the 5? Displacement?
describe SHM and amplitude is 5 centimeter. So amplitude is given as 5 into 10 raised to minus 2 meter. Now time is 0.2 seconds.
Oh, it was centimeter.
Find the acceleration and velocity of the body. So you have to find the acceleration and velocity. See, Royden, what you're doing is wrong.
Yeah.
So all of you listen. Okay, listen. Listen, all of you. So you have to find acceleration. Acceleration formula is minus omega x square. Okay, minus omega x square. Here they are asking
I say same error.
minus omega square x. Omega square x, that is the formula, right?
Yeah.
And 5 centimeter, find the acceleration when the body, okay. So first case, displacement is 5 centimeter. First case, displacement is equal to 5 centimeter. That is 5 into 10 raised to minus 2 meter. So you have to find omega. How will you find omega? Omega is 2 pi by t. That is 2 pi by 0.2. That is equal to how much? 10 pi. Correct?
Yeah.
10 pi radian per second. Now, acceleration will be minus 10 pi square into 5 into 10 raised to minus 2. What you will get? Minus 100,
100 pi square.
5 pi square. 5 pi square, right?
Yeah.
You will get it as 5 pi square meter per second square. You need to find velocity. Velocity formula is what? Minus omega into root of a square minus x square. A is 5, x is also 5. So velocity will become 0 meter per second. This is the first case for x is equal to 5 centimeter. Now for x is equal to 0 also you have to do.
What happened to the cancels that?
Understood. So basically, when the question is in the equation form, you have to do the previous method. If the values are given, use these formulas. Okay, the values are given directly, so use these formulas. Okay,
Don't use that other.
if you're getting it's fine. If you are getting,
I didn't.
I didn't get it. Yeah, you won't learn.
You didn't get it, right? Yeah. Yeah, yeah, after. Or just to go home.
You are not free.
Okay, don't tell that.
Not free.
Plus X outside.
Tuesday.
We need to convert to meters. Minus 5 square meter per second square.
don't copy if you don't understand. Next week there will be test.
Oh,
So happy alone.
Oh, we divert velocity 0.
what if there is?
Yeah, for me.
White test. Test.
That's right.
But no one's coming. Like, no one comes somewhere. I'll be coming.
Yeah, very.
Come on, next Friday.
Arrival time.
Yeah, there.
No, 8:30.
I'll come
That's
back to
it, far we are going.
I mean.
Yeah, but like, yeah, where to reach there at 8:30. People like,
8:30 bus will leave.
yeah, like by 8:30, not like 8:50.
Where are you going?
I'm simple.
In January.
Hold on.
No, after tomorrow. After tomorrow.
Sunday.
Yeah, so most people don't come for Monday. in school.
Oh.
Yeah, they'll take leave. They'll be like,
That's
I won't have a choice.
I mean, last year also it was on Sunday.
Yeah.
I don't know, like they will keep it on like weekends and all, and that too like especially like after weekend like they school like they will keep it on that day. Like last year when like when it was like Sunday, Monday, Tuesday, Wednesday, Thursday, yeah. Like that those are the working days, yeah. That time also they put field trip on Saturday. So like Sunday we had to come to school. So, yeah, I'll have to go. Yeah, I know.
So what's the acceleration for zero displacement? No. What is the acceleration for zero displacement? Yeah, zero. What is the velocity for zero displacement? No. Velocity is not zero. Minus?
Minus root 5.
Minus? Zian continues, Zian.
I got minus 55 into 10 raised to minus
Minus?
55
50 pi into minus?
into 10 raised to minus 2.
Correct.
Doesn't that get cancelled? Zero.
Do with zero, all of you do.
10 raised to minus 2 is what? But 10 raised to minus 2 is what?
Wow.
Oh, amplitude.
I want minus 25.
Oh, I think that's for displacement.
Wow, see.
Could you multiply for outside?
Oh, wait, this is zero.
Oh, it's zero.
It's so meter per second.
Oh, wait, that's square.
Wait. Again. Yeah.
It's here.
Not then. Involved on the. Yes, sir. Yeah. You feel. No, I got good, a lot of parents.
Right.
No, I'm not free. I'm not sweat.
Okay, what, let me follow your scooter.
No,
He's gonna kill him with the bar.
he called it.
No, not that.
Yeah,
I was the shop. I feel that. Yeah, no.
Finish?
I'll come with you.
That's it. Only that's it. That's it. Yes.
Oh, he's gonna use your.
Oh my god.
Yeah, and he's
Yes.
gonna jack it.
Oh, then you
Not tiny over jacket.
leave it. I'll go.
Oh. No, I would not take that.
Royden, what is the value you're getting for velocity?
Minus 55 to 10 raised to minus 2.
Yeah.
I took 10 raised to minus 2 as for like displacement. This
What do you put it?
Negative 50.
Okay, tell why. Why am to minus 4 that come from?
Okay, so acceleration will be zero. That is okay. The velocity will be minus 10 pi root of
Yes, he's like.
Oh, okay. Doing it.
5 into 10 raised to minus 2 the whole square.
5 into 10 raised to minus 2 the whole square. So it will be minus 10 pi
5
into
into 10 raised to minus
5
2.
into 10 raised to minus 2. So minus 0.05 pi, right? That's it? Meter per second. Okay, got it right?
Yeah.
Got it all of you? No? Where you're not getting?
Oh, like.
See, why?
No, it's 0.5. 0.0.
What?
0.5.
Just 0.5?
Yeah, just 0.5.
Okay, just 0.5, okay.
Pi is pi, no.
Yeah, 50, right? Yeah.
The pi square not pi, yeah.
Only you.
Why you're squaring? There is no pi square. Where is pi square and not coming? Pi is not inside the root.
A whole thing. You can't subtract it.
Only I can.
Not.
Okay.
Who is so bad?
I give steps. You won't understand anything.
Anaga, got it, Anaga? Steve,
Yeah,
are
ma'am.
you getting? Okay. Write the next question.
This entire thing. Only
I don't.
A particle of mass 10 gram. A particle of mass 10 gram is executing SHM along a straight line. A particle of mass 10 gram. A particle of mass 10 gram
Yes.
is executing SHM
CQ. Yes.
is executing SHM along a straight line. Along a right, along a straight line with a period of 2 seconds.
Right.
With the period.
With a period of 2 seconds and amplitude of 10 centimeter. And amplitude of 10 centimeter. What is the kinetic energy? What is the kinetic energy when it is? What is the kinetic energy when it is 2 centimeter and 5 centimeter? 2 centimeter and 5 centimeter. 2 centimeter and 5 centimeter from its equilibrium position.
it's 5. Yeah, that's for X.
Yeah, equilibrium position.
How do you account? How do you account?
How do you account?
How do you account for the difference between these values?
How do you? Wait, what does
How
that
do
mean?
you account for the difference between two values? How do you account for the difference between two values?
These two.
Yeah. What do you mean by that?
Like time zone.
The difference between two values.
Yeah, see.
Okay.
FPI. No, wait. Better to back.
So mass of the particle is given as 10 gram.
10 carats.
How will you convert it to kg?
Yeah, 10 divided by 1000.
Okay. Straight line with a time period of 2 seconds. Time period is given as 2 seconds. And amplitude is 10 centimeter.
We always need to convert to kg and meter.
Yeah.
I see.
Otherwise, you will get in an erg and all energy instead of joule. Find the kinetic energy. What is the formula for kinetic energy? Half mv square. What is v? Minus omega root of a square minus x square. Okay. So you have two cases, 2 centimeter and 5 centimeter. So first case we will do x is equal to 2 centimeter. Velocity will be minus omega root of a square minus x square. What is omega? What is the value of omega given? It's not given. Time period is given, right? Find omega first. All of you find omega.
Five, yeah.
Find omega.
9 and 5, yeah.
Yeah,
Nice.
I didn't even do it, but like.
Yeah, it's answer.
Yeah, even the displacement to
Yeah,
Yeah,
that I do.
Trust.
yeah.
Agreed.
Agreed.
More nice.
Oh yeah.
Low
Father is
Old. Yeah, his grandpa's Vijay also. Yeah. Probably. Time skip. Okay. Samijay time skip.
Yeah.
Yes.
What is omega? What is omega?
Of the building.
Huh? Omega is what?
Pi.
2 pi by 2 pi. So minus pi, root of what is a? 10 raised to minus 1 into what is x? 2 into 10 raised to minus 2, right? So I'll write it as 10 into 10 raised to minus 2 itself, okay? So it will be easy for calculation. 10 into 10 raised to minus 2 minus 2 into 10 raised to minus 2. Correct, right?
Yeah.
Square is there.
What?
Square is there. Now this will be minus pi root 96 into 10 raised to minus 2. That will be the answer. Now we keep it like this because you need to find kinetic energy. Kinetic energy is half of v square.
Oh God.
Okay, it will be v square. So don't find root of this and all. Okay, kinetic energy is half m v square. M is what? 10 raised to minus 2. Half into 10 raised to minus 2 into minus pi square, right? So it will become pi square into 96 into 10 raised to minus 4. So you will get it as,
What 11 square?
no, pi square.
Oh.
40, what is this? 48, right? 48 into 10 raised to minus 6 pi square. 48 pi square into 10 raised to minus 6. Joule. Correct, right? Similarly, you have to do for x is equal to, what's the value given? 5 centimeter. So this v will be minus pi root of 10 into 10 raised to minus 2 v whole square minus 5 into 10 raised to minus 2 v whole square. So it will become root 75 minus 5 root 75 into 10 raised to minus 2. So kinetic energy will become half into 10 raised to minus 2 into
The best.
So method you understood? Don't copy.
Don't copy.
So they are asking about kinetic energy. So there are two different kinetic energy values, right? Depending on the displacement, kinetic energy will be changing. Lesser the displacement, more will be kinetic energy. See, displacement 2 centimeter and 5 centimeter. Lesser displacement, you have more kinetic energy. Because near the mean position, kinetic energy is maximum. Correct. Okay. So lesser the displacement, kinetic energy will be more. Understood? Understood. So go through these problems. Okay. Next class, we will finish this chapter. Okay. Chapter 2 more topic only. 2 more small topics to be completed. Okay. Is this clear? Anaka understood, Anaka? Sabha, you understood?
Yes, ma'am.
Yeah.
Ma'am, Rohan saw.
Rohan went to India.
Yeah. He came for.
No, he is outside.